Hi everyone, I'm going to be doing question 4 of week 6B homework. So today we're looking at a single slit diffraction problem. So first, I drew out what's happening here. So we have a light passing through a tiny slit, which I wrote here, and my pen's too. And in a barrier, and it's landing on a screen over here. And when the light passes through a tight opening, which I represented W, it spreads out and creates a pattern of bright and dark spots on the screen, like I represented here, like dark, light, yeah, so on. And so, before we do any math again, I'm gonna go over all the variables again, so we're on the same page. So we have lambda, which is the wavelength, and so wavelength is just the distance between two consecutive crests or peaks of a wavelength. And because it's like a distance, its SI unit will be in meters. W is the slit width, and it's just the size or physical width of the opening the light passes through, and its SI unit is also in meters. Theta, theta is the diffraction angle. So it's an angle that tells us where the dark spots or dark fringes end up on the screen, and it's relative to the middle. So like kind of like here. And so its SI unit is in radians or degrees. And then M, lastly M, we have M, which is the order number of the dark fringes. So it's an integer like 1, 2, 3 that basically counts which dark fringe you're looking at. So the first dark spot, second dark spot, etc. And because of that, it has no units and it's just a pure count. So the main equation locates where the dark spots appear in single slit diffraction. So that would be sine theta. Hold on. Sine of theta is equal to m times lambda over w. And so why are we using this equation? Well, it's because it connects the angle of the dark spots, theta, to the wavelength, lambda, and the slit width. So the problem asks if we double the wavelength, making it 2 lambda, what do we need to change the slit width to do the exact same diffraction pattern is produced? So for the pattern to stay identical, the angle theta for the dark fringes must stay exactly the same, which means the ratio of wavelength to slit width has to stay constant. So to set this up mathematically, our original ratio was lambda over W. So if we rewrite our new wavelength as lambda 1 is equal to 2 lambda, and our new slit width is W, we want the new fraction to equal the old fraction so that the angle theta doesn't change. So that would mean lambda over W, whatever, is equal to lambda over W. And so if you look at both sides, to keep these two fractions equal, W must be equal to 2W. So if we double the top of the fraction, the wavelength, we need to double the bottom of the fraction, the slit width, by the same factor so that the two s's cancel each other out. So that means 2 lambda over 2W is equal to lambda over W. So if our wavelength doubles to 2 lambda, the slit width W must also be changed to 2W. And looking back at the multiple choice questions, the correct answer is 2W. So thank you for watching.